So I want to devote a smaller module to summarizing the sort of information that we can glean from this more careful exploration of working memory. So our working memory capacity really dictates the amount of information that we can be consciously aware of and the amount of information that we can consciously manipulate to make decisions or inferences. What we learned is that our working memory capacity is limited, and we knew that before, but our working memory duration is also limited, so that it's not just the amount of information and the complexity of information that are problems with working memory, it's the retention of information over longer periods of time. And in fact, what we saw is in both the visual spatial sketchpad and the phonological loop, information will decay without rehearsal. In the case of the phonological loop, we have articulatory rehearsal, saying it over and over again. In the case of the visual spatial sketchpad, we have those visual spatial scribes redirecting our attention to those points again to refresh that information. Researchers have been quantifying the capacity of working memory at least since Miller's 1956 paper, The Magic Number 7 plus or minus 2. So Miller's range of working memory capacity in human beings was 7 minus 2, or 5 at the lower end of variation, and 7 plus 2, or 9 at the upper end. So he thought that captured most of the variability, most of the differences between human beings of working memory capacity. Notice that this is a measure that applies to the phonological loop and to nothing else. And so researchers now, when they talk about working memory capacity, focus in on the individual components, those individual memory stores of working memory when they're thinking about capacity. The visual spatial sketchpad is thought to have about 3 to 4 items as its maximum capacity. Now, interestingly enough, those items can have 1 to 4 features. And you would think, well, if there are more features, then the information is more complex, and so you could have fewer items. But it turns out that this isn't such a determining factor, that 3 to 4 items is pretty constant, no matter how many of those 1 to 4 features are associated with each of the items. But the 3 to 4 items is a hard limit. There doesn't seem to be any additional visual spatial memory capacity beyond that, no matter how many features or how few features the individual items have. The phonological loop is thought to range from between 3 and 8 items, and it is tied both to the size, the amount of information, and the complexity of the information. The number of items, whether it's 3 or 8, actually is determined in part by how large the items are. And that's usually measured in experiments by time to speak. So anti-disestablishmentarianism is a much more complex word to keep in your phonological store than but. And so as a result, you can store a lot of 3-letter words in comparison to a lot of 12-letter words. So size is part of the complexity dimension. Another part of the complexity dimension is similarity between items. So items that sound a lot alike are more complex from the perspective of our phonological loop, and hence it lowers the number of items that can be stored in the phonological loop when those items sound a lot alike. When they sound quite different, then you can store more items that are less complex. So that number, 3 to 8, that capacity, that is the size of working memory, but that size is also limited by the complexity in terms of the length or complexity size of the word and the complexity as an expression of its similarity between items. Working memory has a strong genetic component to it, so that your working memory capacity is largely fixed after your initial development. And we have a limited at best ability to modify working memory capacity in the form of increasing working memory capacity. So there's been a fair amount of research about brain training and about all sorts of different attempts to enlarge working memory capacity. But none of those experiments show a significant increase in the size of working memory as a result of brain training or activities or occupations in life. It doesn't look like using working memory a lot actually has any impact on its size. Now, we can modify or mitigate at least the limitations of working memory by grouping things together. So, for instance, the average phone number, at least without the area code, is 3 numbers and 4 numbers. And that's done, in fact, because of Miller's research. What we realize is that some people can't remember 7 numbers. And so we'll chunk them together into one 3-digit number and one 4-digit number. And that helps to mitigate that capacity by grouping them together into slightly more complex units. But limiting the units now to 2, we have a better chance of the person remembering that information. Working memory capacity does decrease with age. As you get older, your working memory capacity decreases. There's some research that suggests that brain training, or just in general being active intellectually, will mitigate that decrease, will make it a little less dramatic than if you're not intellectually very active. Working memory, of course, is implicated in fluid intelligence. The ability that we have to consciously, adaptively problem solve, make decisions in real time using our working memory, using our conscious awareness of the problem. So working memory serves as a gateway to at least some forms of long-term memory, particularly what are often called declarative or explicit long-term memory stores. Those memories, generally speaking, have to be processed through working memory in order to be consolidated into long-term memory. In sum, then, what we learn by examining contemporary theories of working memory is that the story that I've been telling up to this point, working memory capacity is small, that's a pretty superficial tagline for a more complicated and nuanced story. But the general points that I was making earlier on about the limitations that working memory imposes upon our native inference and decision-making capacities, and that still holds up. We just have a much more nuanced understanding of the ways in which our working memory is limited and the ways in which we can adapt and use our working memory. In the next section module, we'll pick up by looking at some of the features from our evolutionary history that help to strongly shape our native inference and decision-making strategies.